Okay, assalamu alaikum everyone. This is a group 4 assignment, course EMMN 4711. The topic is plastic injection molding by bottle cap. I am Raad Nasrallah, matric number 195804. I'll be presenting week 8. Okay, so for the design of the plastic part, the design that we chose was the bottle cap. So the bottle cap is a plastic lid that is used to contain fluid in a bottle while at the same time being an opening of the liquid to escape. So it is a round cap with ridges on the outside surface to create more grip for the holder. So it can be opened and closed easily. The diameters of the bottle cap are a radius of 15.25, thickness of 12.43 millimeters, and a ridge gap of 1.54 millimeters. This is the design that was done by CATIA V5 software. Next, please. Material properties. Material used for this type of bottle caps is polypropylene since it is odorless, non-toxic, and is an excellent resin, which means it's easy to mold. However, they have a shrinkage problem and shrink sometimes around 2%, which can lead to deformation problems. The material is cheap, environmentally friendly, and easy to work with. Therefore, it's preferred over other materials such as polyethylene or PPT. Next. So the type of injection used. Injection mold. Standard mold. Standard mold consists of clamping plate, injection system, which is a stripper plate, ejector rod, retainer plate, as well as cavity plate and mold plate. The advantages of the standard mold is inexpensive, simple to create, compatible for most designs, and dependable. Next, please. Okay, the position of molding related to the parting line. Parting line refers to an edge where the two halves of the die meet on the part geometry. The type of parting line used may be perpendicular to the mold, vertical, curved. The parting line of this cap is the maximum outer diameter of the cap, so that the parting surface is taken on the inner bottom of the cap. Okay, so as we see in figure 1 and figure 2, the outer surface in yellow color, as shown in figure above, is parting line. From figure 2, we can see the inner surface of the bottle cap is red in color and the outer surface of the bottle cap is green in color. Most of the time, the parting line defines the outside and inside surface of the part. Draft CAD analysis tool was used as it is a quick and powerful way to view and develop parting lines of die casting part models. Next. Okay, so the number of cavities. The number of cavities depends on the size of the product. Bigger plastic products are created using a single cavity mold, while small products are made using 4 cavity molds. For our design, we can use one mold with 2 cavities since the part does not require air pressure expansions. Number of cavities has been shown to be almost always 2 in the case of bottle caps. Okay, as we can see here, this is the shape of the cavity insert and mold core that was conducted on CATIA V5. Next, please. And this is all for me.
Okay, thank you, Riot. I'm Parsa Sultani. My metric number is 199703, and I will be showing the week 9 progress. All right, so first we have the type of runner systems. So first of all, what are runners? Runners must be designed to swiftly fill the chamber, and the molded object must be easily ejected and degated. So there are 3 types of runner systems: normal runner systems, hot runner systems, and cold runner systems. For our project, we used the standard runner system. And the reason for that was because it's cheaper and it's less sophisticated than the hot and cold runner systems. And it has lesser thermal resistance in producing the product. So here we have the sprue. What is a sprue? A sprue is the vessel for injecting the melted plastic into the mold in order to attain the desired product. Since our product is a bottle cap with low amounts of required plastic, the design of the sprue can be very simple. So as you can see here, we have the isometric view and the top view of the sprue. These were both done in ANSYS. And it is very simple sprue because this was enough for our requirements. So the sprue can't be on itself. We need sprue bushing. So sprue bushing is a metal element that connects the mold to the injection machine in plastic injection molding. The sprue is also a component of the runner, which allows molten plastic material to be injected into the mold via an injection machine's nozzle. So the sprue hole diameter should be greater than the injection machine nozzle diameter, which here we have the sprue bushing, and as you can see, um, it is bigger than the nozzle diameter. So we need a cooling system, and there are many cooling systems. So we needed to select a cooling system out of the amount that there is. So first of all, why do we need a cooling system? Because after the molten liquid plastic material has been injected into the mold cavities, cooling happens because we need to harden the plastic. The cooling process is dependent on the mold cooling channel designs. Cooling channels are machined into the mold tool using normal processes like drilling or milling. To ensure that the entire part is efficiently cooled, standard cooling channel design is best suited for parts with relatively simple geometries. And as you can see, our part has very simple geometry. It's just a bottle cap, so not much complexity is required. And here we have the layout of the cooling systems. The diameter of the cooling channel is 8 millimeter. The distance between the cooling channels is 16 millimeter, and the distance between the mold cavity and cooling channels are also 16 millimeter. And we have 7 cooling channels in total. So next we have the stationary mold plate. The stationary plate is a critical component of plastic injection molding machines. During the clamping of molds, force is produced against the face of plate, which will result in deformation of plate concavely. As a result of bending of the plate, tight bars also result in uneven loading. The uneven loading results in the premature failure of the tie bar, which can lead to the breakdown of the machine. All right, so that is all for week 9 progress, and next we have the week 10 progress, and I will pass it on to our friends. Thank you.
Thank you, my friend, for the presentation. So I will be continuing the presentation on week 10 progress. So what are we required to do for this is we are required to design a ejector layout. So as you can see in the picture at the right side, here is the ejector layout of our injection molding system. So it consists of one mold with two cavity. This is because for the production of uh, bottle cap, it is rarely used one mold with one cavity. Usually one mold with one cavity are used for a larger product. So because of our product is small, so we only use one mold with two cavity. So for this type of ejector, it uses a stripper plate where the stripper plate has ejector pin that will eject the finished product. And lastly, the stripper plate with ejector pin will be pushed away by a knockout bar. So next, this is the stripper plate that I have mentioned earlier. The dimension is 100 times 30 millimeter. Also, the ejector pin is 15 times 5 millimeter. So we don't need a very big ejector pin, just big enough so that it can push our product from the mold. So here also we have an ejector system. We use an ejector type with automated gate separation. So there are also other component aside from stepper plate. We have a retainer plate. We have a bushing. We also have the movable mold plate where the mold will be going upward and downward when the molding happen. We also have a base plate. So basically all these components that I have mentioned, it consists of same size as the super plate, except for the movable. It is slightly smaller than the stripper plate. So for mounting and clipping plate, I will pass to another presenter. Thank you.
So thank you Badrul for the presentation. Okay, Okay, before that, my name is Amin Najmi bin Hussaini. My metric number is 195921. So I will continue the presentation here. So here we proceed to my part, which is mounting of clamping plate. So basically the clamping plate is a stationary plate set to withhold the clamping force. It is required so the resin doesn't spill out once injected, and it stays shut against the movable plate. So basically in the figure below shows the clamping plate and depth of pockets of the clamping plate. So next slide. Okay, then the components for actuating ejection. So basically the ejector pins okay, so basically the ejector pins sleeve with retainers and backing plates are made of ejection assembly to reduce out of balance force that might cause premature wear or damage. It is ideal to have the complete assembly symmetrically balanced wherever possible. Many ejection systems require a high amount of integrity on the part of the mold designer to overcome ejection issues. The developing effective system may be difficult due to the interaction of several elements. The cavity shape and geometries, as well as the material and kind of cavity construction, must all be considered. So next slide. So here is the ejector return, which is the return pin or pushback pin, which is situated or connected together with the ejector pin cover plate. It is the type of ejector return for this case. So return pins are components that allow the compression mold to return the entire ejector subassembly to its previous position. If return pins were not used, the ejector's subassembly would be returned through ejector pins, which would damage the ejector pins ends and change the appearance of the item. So next slide. The last one is the mold venting. So basically, injection mold venting slot serve with two uses. So the first one is to remove air from the plastic injection mold cavity during the molten plastic material injection process. So the second one is to remove the gases produced throughout the injection molding process. Venting slots must be strategically placed, especially for thin wall goods for those far from the gate. Venting slot for small size or exact space should be carefully considered as well, as they can protect the goods from the surface burns, insufficient filling, and other issues. So I think that's all for the. So we proceed to the week 11. So for the week 11 progress. So the first one is the stationary clamping plate, ball and hole pattern. So in turn, the cavity mold is held in place with the help of the stationary clamping plate. A seat for the runner system is located at the top of the station plate. The location ring is inserted into a ball hole pattern on this plate. The purpose of the located ring in the mold is to make it easier to position the mold such that the nozzle hole is in the clamping plate. So basically here is our design for the stationary clamping plate. So next slide. So the locating ring injection mold is a simple part but very important when the mold base attached to the injection machine. It is used to locate or align the sprue of the mold and nozzle of injection machine. It is also usually in the center of mold. Sometimes it is offset to reduce mold. Locating ring is about the same size of the sprue bushing as it will be assembled together. So basically in the figure below is the locating ring which is drawn in CATIA. So here is the dimension of the, and the right side is the dimension of the locating ring. So next slide. So next one is the assembly of cavity insert and mold cores. So basically, cavity plate is a plate used to create a cavity that will be filled with the plastic material and form the plastic component. Usually, it is made of the mild steel. The core plus plate project into the cavity place and creates hollow portions in the plastic components. So this core plate is usually made of hardened hot die P20 steel without hardening after core machining. For the injection machine, the cavity plate is shown. So the cavity is shown in this slide. So which is the reddish color, which is the cavity plate is the reddish color, while mold core is the opaque color below. So as you can see in the slide, figure shows cavity plate and mold core for the injection machine. So next slide. So next one is the assembly of injection molds. So as you can see here is the final assembly, which from the asymmetric view. We also have provide the front view, the side view, and the top view. That's all from us. So thank you very much.